Time. What is it? Where does it begin? Where does it end? Was there time before the Big Bang? And will it have an end? When our solar system reaches the end of its life, when we no longer exist, will time still be there? Is it something that flows independently of everything, of us, of space, moving like a straight line? According to the fathers of classical physics, Galileo, Newton, yes, time is absolute, unchanging, constant, flowing independently of everything. When people say absolute time, Newton is the first who comes to mind. But there was a young man working at a patent office in the city of Bern. Remember him? Do you know what he once wrote in his diary? Newton. I'm so sorry. Newton, Descartes, Galileo, Maxwell, and dozens of other great scientists, names that changed history. With that single sentence, he was essentially dissing all of them. Gentlemen, I'm sorry, but that's not how it works, he was saying. Our rebellious young man, Albert Einstein, a person who once said as a student, "This fact or that fact does not interest me. I want to understand the way God thinks. The rest is mere detail." A man who, even an hour before his death, took his notebook and pencil, trying to write down the final step needed to understand God's mind, the theory of everything. We will talk a lot about Einstein. A lot. His virtues, his flaws, everything. I have so much to say about this man's life and worldview. But today we're talking about time. And to understand time, we must first go back to where everything began. Don't worry, we won't go all the way to Greek mythology or the philosophers of antiquity. Aristotle, Copernicus, those are separate topics we can discuss another time. Let's go to when the concept of time was first studied scientifically. The 16th century. What a century, right? Galileo, Newton, Barrow, Descartes, an age of enlightenment stretching into the 17th century. And humanity first studied time with Galileo Galilei. With Isaac Barrow and Isaac Newton, the concept reached a form that would be accepted for centuries. According to all these scientists, time was absolute and universal. This is what we call Newtonian time. Time was the same for everyone, flowing at a constant rate everywhere in the universe. It could be measured, but not perceived. Newton believed that time and space were completely separate components of objective reality. And he believed that even if everything in the universe vanished, time would continue to exist on its own. Shakespeare said, "All the world's a stage." And for Newton, the one unchanging thing on this stage was time. Even when he described gravity and the laws of motion, ideas that change the world, time was the one thing he chose not to touch, the one thing he assumed constant. That's why I said at the end of the previous video, there was a problem Newton could never solve, something he thought must be God's doing, something beyond human understanding. The clearest sign of this problem was hidden in the motion of Mercury. Newton's laws could calculate everything from a falling apple to Earth's orbit with perfect accuracy. But Mercury refused to follow the rules. Its orbit kept shifting, slightly, but persistently. Some scientists even proposed the existence of an unseen planet, Vulcan, to explain this anomaly. But it didn't exist. Nothing existed that could explain Mercury's rebellion. As long as time was assumed to be constant, there could be no explanation. Now, I want you to do something extremely difficult. I want you to forget everything you think you know about time. Forget how you think time passes. Forget that it flows like a straight line. Forget birth to death as a single timeline. Forget that time is the same for everyone, everywhere, regardless of where or how you live. Forget it all. Because we need to tear that entire perception down. Because it's wrong. All of it is wrong. Who says so? First, Wilhelm Leibniz. For Leibniz, time was simply the way we mentally organize events. Before, after, simultaneous. Then, independently, Immanuel Kant agreed. Time is not something that exists by itself. It is a structure our minds use to organize experiences. According to Kant, things that exist outside us, independent of our minds, are not in time. But it was Albert Einstein who put the final nail in the coffin. In 1905, Einstein's miracle year, he published 4 revolutionary papers, including the special theory of relativity. After more than a decade of work, he published the general theory of relativity, securing his eternal place in history. These are not things we can cover in a few sentences. We'll explore them deeply later. But let's stay focused. Time. What is time? This question haunted Einstein, a huge admirer of Newton, because after Einstein saw Maxwell's equations, he became certain of one thing. The only constant in the universe is the speed of light. No matter who observes it, no matter where you stand, the speed of light is always the same. Which meant something in Newton's framework had to change. Something could not be constant, especially time. Time could not be constant. Let's illustrate this with a doomsday scenario. Suppose the sun suddenly vanished without warning. According to Newton's gravity law, the Earth would immediately fly off its orbit, instantly. Why? Because Newton envisioned gravity like a rope between two objects, an instantaneous force. But to Einstein, this is impossible, because the speed of light is the universal speed limit. Nothing can travel faster, not even gravity. The sun's light takes 8 minutes to reach Earth, and gravity travels at the same speed. So, if the sun disappeared, we would live in total ignorance for 8 minutes. After that, well, the scenario isn't pleasant. This discovery is one of the most important in the history of science. And here's the strange part. We could live our entire lives under Newton's laws and never notice the difference. In everyday life, Newton's laws work 99% perfectly. But the 1%, Mercury, was the crack Einstein couldn't ignore. Einstein had glimpsed this truth at age 16 through one of his famous thought experiments. Imagine a train moving at extreme speed. 2 trees, 100 meters apart, are hit by lightning simultaneously. For an observer on the ground, the strikes happen at the same time. But for someone on the fast-moving train, one lightning strike happens first, then the other. Same event, 2 observers, 2 different times. Now, relativity starts to make sense, doesn't it? Let's try another example to understand the constancy of light speed. In daily life, speed is relative. If 2 cars move side by side at 60 kilometers per hour, each sees the other as stationary. If one accelerates to 80, the relative speed is 20. But this rule breaks at light speed. Light always moves at 299,792,458 meters per second. No matter where you are, how fast you're moving, or how you measure it, you always get the same number. How? We turn to Einstein's most famous equation, E equals mc squared. He originally wrote it as m equals E divided by c squared. In other words, energy and mass are interchangeable. Everything you see, everything you can touch, is actually energy. You are made of energy, and a lot of it. A single paperclip, if fully converted to energy, would release the equivalent of 18 kilotons of TNT, almost the same as the Hiroshima bomb. But let's not drift too far. What matters is this. As an object's speed increases, its energy increases, and therefore its mass increases. Approaching the speed of light, it would require infinite energy. Thus, nothing with mass can exceed the speed of light. But here's the part that defies our intuition. If light speed is fixed, and speed times time equals distance, then time and distance must change. Let's use the famous twin example. Louis and Lisa are identical twins. Louis stays on Earth. Lisa travels for 1 year aboard a ship moving at 99.997% of the speed of light.
When they reunite, Lisa is 31 years old, but Lewis is 81. A 1-year journey for her, 51 years for him. This isn't just theory. It was tested in 1971 in the Heifel-Keating experiment using atomic clocks on airplanes. The clocks no longer matched after the flights. Time had truly passed differently. Hard to grasp, isn't it? But this tiny difference is what allows GPS to work. Without correcting for relativity, your location would be off by kilometers. Everything I've said so far is just a tiny summary of Einstein's special relativity. We haven't even touched general relativity, gravity, or the quantum world where even Einstein became stuck. You might wonder, what does any of this mean for my daily life?
Sometimes I wonder too. It's so hard to grasp. It makes you want to give up. But then I find myself thinking about the universe again, thinking about energy, that everything, every one of us is just energy, that time is an illusion, that everything, our problems, joys, sorrows, perspective is relative, depending entirely on where we stand. And then I realize physics is actually explaining me. It reshapes my entire perspective on life, the universe, society, politics, matter, psychology, on myself. So let's see what we learn about ourselves in the next video. Shall we meet again at the first opportunity? Until then, take very good care of yourself. And as always, I'm glad you exist. Much love.